Okay guys, here is a short video explaining Diels-Alder reactions. This is generally going to be reserved for Orgochemistry 2. These continue our discussion about conjugated dienes. These are quite easy if you remember to number your carbons exactly as I'm about to show you. You're going to have two molecules. This first molecule is called a diene, and this second molecule is called a dienophile. This basically is one big resonance party going on, although I have found that it is extremely rare on tests for you to actually show this mechanism. So here's what's going on. This pi bond between 1 and 2 is going to flip down. Well, now that's too many bonds for carbon 3, so this pi bond is going to exist as a lone pair over on carbon 4. So when this first resonance happened, I now have a carbocation on carbon 4 that is going to attract this pi bond here. So this thing is going to go like that. Well, now that's going to have a carbocation on carbon A. Let's not forget about this lone pair here. And so this is going to go over here. The nice thing about these reactions is that they will always generate this base molecule here. The important thing to remember is that if there was a substituent in the beginning of the reaction, you must account for it in the final product. Let's do a few examples. So here's our diene, here's our dienophile. Always have your carbons numbered like this: 1, 2, 3, 4, A, and B. And that base product is never going to change, so we can just go on ahead and show that. And if you want to see your red arrows, this comes down, this goes over, this flips up like so. And we're going ahead and number these. 1, 2, 3, 4. 4 always connects to A. A is connected to B. B now has a sigma bond going to carbon 1. So there's our base molecule. We can see that we have a methyl group coming off of carbon 2 in the beginning, so we must show it in the end. And we have trans-methyl groups located on our dienophile, so we need to have trans-methyl groups in our final answer as well. And since we formed two new chiral centers at carbons A and B, this thing will have an enantiomer. Moving on to the next one, diene, dienophile. Going ahead and show our base molecule like that. We can see that on our diene we have two methyl groups coming off of carbons 2 and 3. So we can go on ahead and show those. And then we have cis NH3 groups coming off of carbons A and B. So that means we must show cis NH3 groups in our final answer. That just means they're going to be on the same stereochemistry, whether you decide to put them on wedges or dashes is irrelevant in this case. Let's do one more example. For whatever reason, a lot of students are going to struggle when they see an alkyne as part of a dienophile. Now remember, every reaction we've seen up to this point, we only need one pi bond for this reaction to occur and give us our base product. So with this one, nothing's going to change. We're just going to have a pi bond left over. So we're going to go ahead and draw our base answer. And we can see that we have methyl groups coming off of B and A. So we're going to show those. And remember, I only needed one pi bond to form this bond between B and 1 that you see here. So that means I'm going to have one left over. This is the other part where students tend to mess up on test day. So remember, these are sp2, carbons A and B. Let me number those for you real quick. And remember that sp2 atoms have trigonal planar geometry. So that means any bond coming off of an sp2 carbon must be shown as planar or sticks, flat. A lot of students mess up and will show this as a wedge or a dash, and it's going to be points off on a test. If you found this video helpful but need more in-depth explanation and see a lot more practice problems worked out, you can find the full-length version over at orgogoat.com. Please like, comment, and subscribe to help our videos find more students like you, and tell a friend. And if you're interested in private tutoring or want a concept explained that you don't see on our YouTube page, shoot me an email at orgogoat@yahoo.com.